Hey, my wonderful students, this is a short video to help you understand the difference between series and parallel, what to look for, and how to think about them. Hope you have your notebook ready. Let's rock. So series and parallel. The first major difference is that series, if two things are in series, they have the same current or flow arrows I taught you to draw. In parallel, two paths are parallel if they share junctions. Remember, junctions where current splits. So if two paths have the same start and end junction, they're parallel. Now be careful. If each path has one resistor, then the paths and the resistors are parallel. You'll see what I mean, because if one path has got two resistors, then you have to combine them into one before you can say it's parallel to another path. So here's a picture. Notice how I draw the current arrow. There's A, B, C, D, E. The flow of current I goes through A and B. It splits up at this point. That's a junction. I1 goes to the top, I2 goes to the bottom. They recombine here back in I, because current cannot be created or destroyed from the conservation of charge. Since A, B, and E all have the same current I going through it, that means they're all in series. Does not matter what order they're in. However, paths I1 and I2 are parallel, and since I1 and I2 both have a resistor in there, then C and D are also parallel. To find what the equivalent resistance of things in series are, you just add them all up. The equivalence is R1 plus R2 plus R3. For parallel, it's a lot tougher though. 1 over the total resistance of the parallel branches is equal to 1 over the first resistance plus 1 over the second plus 1 over the third. And please remember, if a path has got more than one resistor, you have to combine it through series before you put the mathematics in parallel. So in summary, in series, the flow is the same. They all have the letter I going through it. So the amps are the same, which means the voltage splits up to make it happen. In parallel, the flow is different. So since the amps split, the volts have to be the same for every branch. So here's a cute little table to make to kind of put everything together. For series and parallel, all things in series have the same amps, I. All things in parallel have the same volts, V. What's different about each one, theoretically, is the volts. And as we know from class, the more resistance something has in series, the more volts it has. And the reason is, if you have more resistance, you need more of the push to get the same flow. Whereas in parallel, amps are different, and it's the opposite. If there's more resistance, that path has less amps. So I want you now to look at this series circuit with R1, R2, R3. Assume R3 is high resistance, R2 is medium, R1 is low. Would the amount of total flow be different if they were in a different order? And the answer is, of course, no. It doesn't matter what order they're in. All that matters is how their resistances are compared. Do they have the same current through each one? Absolutely. Since there's only one path, they all have the same current. Voltage is the push from high to low. Does that mean the same amount of voltage make all flow? No. The total voltage is split up. Again, R3 is going to have the most of the voltage because it has the most resistance. Here's our parallel circuit. Notice you have a couple different junction points, but really they're all the same junction points since no flow is changing between these junctions. So in other words, the total current is these three parts added up together. So this is a true parallel circuit. R3 is again high, R2 is medium, R1 is low resistance. Would the flow rate be any different if they were in a different order? Absolutely not. You might think, but if R3 is over here, it's closer. But distance doesn't matter, it's about resistance. And we always kind of assume that these wires have no resistance. So it doesn't matter what order you put them in. Do they all have the same current? Absolutely not. Since the current splits up, more current's going to flow through the lower resistance, which happens to be R1. Voltage is the push from high to low. Do all these need the same amount of voltage to make the flow? Absolutely. Since the current splits up, the volts have to be the same. And a physical way to think about it is, all three of these junction points have the same voltage, which is the beginning voltage of the battery. With that, you now know the difference between series and parallel. You've kind of explained the differences conceptually. In the next video, we'll explain it mathematically. I look forward to seeing you then.